Welcome to day one of One Up Coding. Uh, for the schedule, I'll be uploading these basically 2 hour long live streams uh, on YouTube, as well as editing a couple lessons from this. So, today we're mainly going to be focusing on what is coding, why do we want to code. I know you guys probably experience or see this kind of topic a lot, but it's pretty important to know why we do all this stuff. So let's get into it. So day one, what is coding? What are we going to learn as well? So we're going to be coding in a language called Java, and we're going to be applying those coding skills to what is to beyond what is called the console, and I'll show you guys what the console looks like. And if already have experience working with the console, I will show you how to go beyond just working in that little thingy, that console. And we're also gonna be learning, more about coding and computer science in general. And there is a difference between coding and computer science if you didn't know. So why do we care? Yeah, it's not just for those who want to be engineers. Coding is something that is almost in every single modern profession. Some doctors, or many doctors, actually know how to code. All the researchers, they don't have to, but coding becomes just a very important skill. Whether or not you want to make a website, whether you want to deal with a lot of data, whether you want to just make a program that is a visual aid for whatever you're working on. And again, yeah, it can be fun. Now, I'm not gonna say it's fun for everyone, but it can be fun. It can be interesting. Once you get over the initial difficulty slope, eventually, yes, it'll become fun because you realize all the possibilities and all the things you can just do with coding. So let's keep going. What is coding and what is computer science? What is the difference really? Now, coding, all it is it's a way to take in an input and produce an output. Very simple. It is the backbone of computer science. So yes, you need to know computer science before you need to know how to code before you can learn computer science. But you don't necessarily need to learn how to do computer science before you learn how to code. And again, coding is something that anyone can do. You see third graders, second graders being able to master several languages and maybe even getting a job just because they know how to code. And coding, yeah, it's a universal skill. Not almost everyone, but a lot of people should learn how to code because it's applicable to so many jobs. Now, computer science, it's something completely different. You take a real world problem, something that needs to be solved, and you design a solution using code to solve that problem. And not everyone can do it. Computer science is something that's super competitive because it's so difficult, and it's something that isn't just being able to code, it's being able to do something with your code, and not everyone will be interested in it. And yeah, that's why it's a profession. Coding isn't necessarily a profession, it's a good skill to know, but computer science is a profession. Let's keep going. How do you code? That's a pretty simple question. You're gonna use an IDE, and stands for Interactive Development Environment, and to simplify that, all it is a text editor. If you ever opened Notepad or even just Google Docs, those are all technically IDEs. Some IDEs are better than others because they have more tools. They help you with syntax. Syntax is just what is in your code to make it look simpler or to make it work. The little necessities here and there. Oh, my chair's breaking. That will help. Will help you code. And again, also you will need a development kit. So a development kit will come with every single language that you want to code in. So there is a Java development kit. You're going to have to download the development kit to work to code with it. But all the development kit does is it turns your code files into files that your computer can actually run. So that's all it is. There will be a website if you want to learn Python or Java or anything. There will just be a development kit for it, and then you just start coding. And we're going to be using an IDE or compiler called Codiva.io. Why are we learning Java? Well, Java is a high-level language, which, in contrast to lower-level languages, is easier to understand by the human and easier to read in general. So higher level languages are obviously closer to human speech, so you can read it relatively easily. While lower level languages, for example, something like C or even C++, those are closer to computer speech. You'll see a lot more symbols like the equals and plus and minus signs and the semicolons and colons. You'll see a lot more of those, and it's closer to math. Whereas the higher level languages, you're gonna see a lot more words, a lot more things that you can comprehend the first time you read it. And because lower languages are closer to how the computer talks, it's closer to the math that the computer does. They usually run faster, but Java is a low enough level language, but still enough language to run decently fast while being able to easily read. And also, higher level languages, because they're easier to read, they're usually easier to learn. They sound more logical, and that means that allows us to have a higher range of possibilities. And so again, a compiler, what is that? All it is it turns these high and low level languages, and it turns them into pure computer speak, and that's called assembly line code or assembly code. It's the binary, it's the zeros and ones that your computer can actually read and do something with. Your computer can't just read the letters and symbols by themselves and be able to do something with them. Yeah, the compiler just turns your code into a bunch of zeros and ones for your computer to read. So some languages actually don't require a compiler because it's built in, but something like Java, you have to compile it first before you run it. And there's you don't have to do that manually, don't worry. There's always a program that will help you do that. So let me check time. Okay. What is the point of code? What does it do? Why do we learn how to code instead of just making like scratch programs or something like that? Well, coding, it takes in an input, right? And we store this input in a thing called a variable. You could think of a variable as like just a container or a box that's meant to hold certain things. And variable, essentially to your computer, they're pieces of memory that we can store stuff in. And we can access those variables later using a name we give to the variable. And the whole point of code is to take whatever input you want. Let's say we have a bunch of grades. Our output that we would desire would be our GPA. How do you calculate your GPA? And so you can use code to take in all those variables that have your grades in them and output your GPA. And that completes the program. So how do we use variables, and what are the different kinds of variables? Well, how can you represent data? Well, there's numbers. You can represent them by you can represent your grades by numbers, by 90s or 50s or 70s. All these different integers, right? There's characters, an A, a B, a C, a X, Y, Z. There's also symbols, the space bar, there's the percent sign and the exclamation sign. You can represent data in floats. Now, a float is just an integer with a decimal. So 12.41 blah 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 blah, 5.43 blah blah blah, 3.1415925, all those floats, they stand for floating point variable, and floating point is just whatever comes after the decimal. So that's a little way to remember it, I guess, but if you want to be more accurate than just using integers, you would use floats. So how else can we represent data? We can represent it in strings. And sometimes when you ask yourself, what are the different types of ways you can represent data? It's really just asking yourself, what are the different types of ways we can answer a question? You can answer with a number. What is 5 plus 2? That is 7. What is your grade? Right now, you have an A. What is 3 times 2.7? And you can answer with a float. But what is your favorite food? You can represent that using a string. And a string is just a bunch of characters stringed together. That's why it's called a string. So strings are, my favorite food is a cake. My name is Luke. The name of this program is 1UP. And another data type that's very important and sometimes overlooked is how else can you answer a question? Well, what if they just ask you a yes or no question? Yes and no are strings, they're words, right? and a string is just a word or phrase or sentence. But a yes or no question, you can only answer yes or no. And so if someone asks you, do you like cake? Then you can answer yes or you can answer no. And so we represent yeses and nos with a thing called a Boolean. So yeah, there's a scientist named Boolean whatever, and he he worked a lot with yeses and nos. So that's why we call true and false Booleans. So if someone ever says this variable is of type Boolean, all they're saying is that variable is either true or false. And so in the future, we're going to be learning about more complex data types, something that can't be described with one piece of data. And but that's for later. First, you have to get down the simple variables first. This is how we're going to use variables in our IDE. Now, this is a lot, right? I'm throwing, what is this? What is this? What are these? Why do you have the back? Excuse me. Why do you have the brackets? And this is okay. What are classes? What does public mean? What does static mean? Why do we have void and main and string arguments? What does it all mean? In order to answer all those questions, we first have to learn how code in Java as a whole works. But don't worry, just focus on trying to practice try to practice typing these things for now, and because they'll be used in basically every single Java program. Yeah, for now, just let's go over these topics, right? Let's stay away from the code for now. Let's try not to overwhelm ourselves. Let's just think. Let's review the topics. So we will be learning Java. It's a coding language that's used to solve computer science problems. It's a high-level language, which means it's easier for you to read. Coding is the backbone of computer science, and it's necessary. It's a necessary skill in almost all modern jobs. Coding takes in inputs and yields outputs. So it takes something in and spits something out. And we do this by taking in things, putting them in variables, doing something with those variables, and then spitting whatever was in those variables out again. And these variables have different data types. They can be represented with integers, numbers basically, strings, characters, booleans, and more complex data types that we will learn in the future. And we will be getting into the fun stuff very soon. So yeah, I'm sorry this was a very boring day, but again, coding is a long, sad, slow process, and it takes a little getting used to. That was day 1. Thank you guys for watching. I'll see you guys next time.